Okay, so since we have talked about inverse functions and we've talked about trig functions, let's look at the derivative of inverse trig functions. Now, you can see the first three formulas here across the top of the page. You do not have to memorize these. I'll give you these formulas. But what I want to point out to you is as we've seen before, the derivative of the cofunction is the exact same formula, just with a negative. So like you can see, the derivative of inverse sine and the derivative of inverse cosine are identical, except for the cofunction has the negative. So as we saw before, the ones that start with C have negatives. So the same thing is true with tangent and cotangent and with secant and cosecant, as you can see further down your page. But again, I will give you those formulas. So when we look at f of x is equal to inverse sine of x squared minus 1. If this was just a plain x, then I could use the formula exactly as it is. But since it's a quantity, I need to use chain rule. So remember, with chain rule, when we have a quantity here, we're going to do the derivative of the outside times the derivative of the inside, the derivative of the quantity. So for us, our quantity is x squared minus 1. That's going to be our u. All right, so let's work on our formula then. That's going to be 1 over the square root of 1 minus u squared. 1 over the square root of 1 minus u, x squared minus 1, squared. Now we need to multiply by the derivative of u. All right, so again, if u is x squared minus 1, the derivative of that would be 2x. So that's where we're getting our derivative. Now we just need to clean that up a little bit. So 1 times 2x is going to be 2x in our numerator. In our denominator, if we do x squared minus 1 squared, that's literally x squared minus 1 times x squared minus 1. That's going to be x to the 4th minus 2x squared plus 1. But then that negative out in front is going to change every one of those signs. So we're going to get negative x to the 4th plus 2x squared minus 1. Then you'll notice that the 1 and the negative 1 can drop each other out. And in our denominator, everything that we have left has an x squared in it. So if I factor out that x squared, this square root of x squared, we could take as an x on the outside, and then that x would cancel top and bottom. So if you want to write that as in that way instead, if you want to fill in that extra step and just pull out that square root of x squared and make it an x out here and cancel it top and bottom, you're welcome to, but you also can cancel it here under the radical since it's something being multiplied. All right, so now what we have left is 2 over the radical, and you also could multiply top and bottom by that radical. So if you need to get the radical out of the bottom, you could rationalize it. I'm not going to require you to get that radical out of the bottom. That's not what we're focusing on right now. But you could see we could write it either way. All right, so let's look at another example with inverse sine. All right, so this time we've got 1 over inverse sine. So the first thing I'm going to do is rewrite it so that it's to the negative 1. So now I can use my power rule. All right, so anything, no matter what's in here, anything to the negative 1, when we do the derivative of that, it's going to be negative 1, that thing to the negative 2, right? So anything to the negative 1 would be negative 1, that thing to the negative 2. So for us, that thing, our u value, is going to be inverse sine. So we've got negative 1, that thing to the negative 2. Now we need the derivative of that thing. Well, the derivative of inverse sine is just the formula that we had just a moment ago higher up on the page. And that's it. That's all the calculus. Now we just need to clean it up a little bit. All right, so we could go through then and move the inverse sine down to the denominator so that it wasn't negative. We've also got that radical in the denominator that you could leave there, or you could rationalize it. So either way, here it is not rationalized, and here it is rationalized. Either way is perfectly fine. All right, so then for our last example, we've got a product, right? You've got x times inverse tangent, so we're going to need to use product rule. we're going to need to do first times derivative of second plus second times derivative of first. All right, so first is x. We can see that right there. Now we need the derivative of second. So we need the derivative of the inverse tangent of the square root of x. Now, you can see this is not just a plain x, so we're going to have to use chain rule. So we're going to think of this as u. So we're going to say 1 over 1 plus whatever our u is, which in our case is the square root of x, squared, because again, that's our formula, right? Our formula is 1 over 1 plus x squared. And since we don't have a plain x right here, we have a quantity u. Ours would be 1 over 1 plus u squared, and our u was the square root of x. All right, now we need to multiply by that by the derivative of u. So if f of x is x to the 1/2, then the derivative of that is just 1/2 x to the negative 1/2, or you could write it this way. We've done that same derivative a ton of times by now, but again, that's the derivative of the inside. All right, so again, what we've got is first, this whole thing is derivative of second, because we used chain rule and we did derivative of outside times derivative of inside. All right, then we need to multiply that by, add to that second times derivative of first. So second was inverse tan, and since the first was x, the derivative of the first would just be 1. So this is our challenging part right here, and then the rest of it is straightforward. So first times derivative of second plus second times derivative of first. All right, and then again, we're just going to clean it up a little bit. So a couple of different ways that we could write this. The square root of x squared is just going to be x. You'll notice here that you've got x to the 1 and x to the 1/2. So when your bases are the same and you're dividing, you subtract your exponents. So that would be x to the 1/2 in the top. So you could write it as x to the 1/2, or you could write it as square root of x, either way. Now that's just going to be 2 times 1 plus x down here. So let's distribute that 2, and that would give us 2 plus 2x. And so this would be our final answer. And again, for each of those square root of x's, you could write those as x to the 1/2 if you preferred. All right, so that is the end of section 3.7.